Hello and welcome to a new Kicad tutorial. In this Kicad tutorial we're going to calculate the power in the resistors using LTspice. This is Kicad tutorial 1.9a. Now remember we are now at symbol number 10 R1 6.8 kilo ohm resistor. We must now assign a footprint to this resistor. And since we clicked on it, this is a resistor R1 6.8 kilo ohm. This is the LTspice simulation circuit. The corresponding resistor in the LTspice simulation circuit is R3, also 6.8 kilo ohm. We at this stage we want to calculate the power consumption in this resistor, and to do this we start the simulation, but we're interested in the power consumption in this resistor, so we're going to press Alt and then press left click on it, and there you can see this is the power consumption curve in R1, the light blue trace. There you can see it's voltage times current amps in resistor R3, which is R1 in Eeschema. You can also ask LTspice to calculate the average power consumption in the resistor R1, and you do that by Control and then left click on it, and LTspice therefore accordingly calculates the average power consumption in resistor R1 in Eeschema, and it is 403.55 nanowatt over a 1 millisecond period. And you can see it has briefly two power peaks, after which nothing really happens. It settles down to more or less zero. So it means that a quarter watt resistor is more than adequate. The next resistor is symbol 11 R2 35.7 kilo ohm. It is this R2 35.7 kilo ohm resistor in Eeschema. In the LTspice circuit, it is also R2 35.7 kilo ohm. And we want to calculate the power consumption in R2. And we do that once again by running the simulation. And we want the power consumption in R2, and therefore we press Alt and left click on it, and there you can see, just make it a bit bigger for you, in this light blue trace over here, this is the power consumption in R2, volts times current I, amps, and we can ask LTspice once again to calculate the power consumption, average power consumption, and we do that by Control left click on this, and according to LTspice the average power consumption in this resistor is 104.69 microwatt over a 1 millisecond period. This indicates once again that the power consumption is very low, and a quarter watt resistor should be more than adequate. As you can see, it more or less settles at 130 microwatts. It starts at 0 and then it shoots up, and that's why it's the average power consumption over the 1 millisecond period is 104.69 microwatt, whereas it settles at 130 microwatts. The next resistor we're interested in is symbol 12, resistor R3, 20 kilo ohm. It is this resistor in Eeschema R3, 20 kilo ohm. In the LTspice circuit, it is R1, 20 kilo ohm, this resistor over here, and we are interested in the power consumption in this resistor R1. And we do that once again by running the simulation and clicking on the run icon. I'll click on R1. And this is just to make it a bit bigger so you can see it better. You can see it starts at 0 and it shoots up to underneath 72 microwatt. And it seems to stay there. You can ask this. This is the power consumption plot in the resistor, and we can ask LTspice to calculate the average power consumption by clicking Control and then left click on it, and as you can see, the average power consumption over a 1 millisecond period is 58.477 microwatt, which is far below a quarter watt resistor should be able to handle. The last resistor we want to know the power consumption in is R4, 0.033 ohm in Eeschema. It is also R4 in the LTspice circuit, and we want to know what the power consumption in R4 is, and we do that by running the simulation. Calculate the power consumption in R4 by pressing Alt and then left click, and there you can see the graph of the power consumption over 1 millisecond. I just want to make it a bit bigger for you. And as you can see, it starts at 0, then off at about 0.1 millisecond, it shoots up until it past 1.3 watt. And it stays there up until about 0.25 milliseconds. It drops down to 0. Then at 0.275 milliseconds, it shoots up again, overshoots a bit, but then it peaks at around 0.2 watt, and it settles there more or less. And we can ask LTspice to calculate by pressing Control, left click. As you can see, according to LTspice, the average power consumption over this period is 27.214 milliwatt. I think this is enough for now. Next time we will choose the resistors and assign their footprints. I do leave links in the description below. If you have any questions or suggestions, leave them in the comments below. Please click the subscribe button. Thank you for watching, and goodbye.